All right, now we can start. Welcome back, everyone. Hope you had a really good week. And so today was supposed to be like there's not supposed to be class today, but since March break got postponed to April, so there is class day. And I believe that the Saturday where the April break happens, there won't be class during that time. So I'll keep you guys updated when that is. But yeah, so what are we learning today? Today we're learning about sequences and series. Some pretty cool stuff. True, yes. Some exciting stuff, sequences and series. We'll talk about those in our presentation today. But let's get to it. First, let's talk about sequences. So before we jump in to the actual definition, can someone maybe tell me what do you think a sequence is? Just unmute yourself or type in chat. What do you think is a sequence? It is yeah, that's good. Yeah, that's a good point. It has a pattern. It's part of the definition. Anyone else want to share their thoughts? What do you guys think a sequence is? A list, yeah, that's also correct. List is also a good way to define it. Okay, let's move on. So those are some pretty good points you guys made there. Oh, I think we have everyone now. It's perfect. People joining. All right. So let's look at what a sequence actually is in mathematical terms. All right. Oh, and look at that. Now the the black bar down here is no longer blocking the thing. It's perfect. Let's see. Turn on the laser pointer. There you go. All right. So what is a sequence in mathematical terms? A sequence is a list of ordered terms. So terms like each number or something. A list of ordered terms. So as you mentioned, list, that's part of the definition, that shares some pattern. And pattern is what I believe Aiden mentioned. So yeah, that's also part of the definition. So combine those together and you get your actual definition of a sequence. Just good job, guys. So yeah, that's what sequence is. And there are a couple types of sequences. First, we'll look at they can be infinite sequences. So for example, you have 1, 2, 3, 4, 5, and so on. So basically, if you see the ellipses, so the 3 dots here, that's how you can tell it's infinite. And then finite just means it has a set number of elements inside the sequence. You see, for example, 1, 4, 9, 16. You said this is the perfect squares in order, but you see there's only 4 of them. So that's how you know it's finite. All right. And then look at this diagram below here. This is how you can what a sequence basically looks like, right? So you have starting from first term, then you go to second term, third term, fourth term, so on. Well, this is an infinite sequence. So here it says 3 dots means goes on forever. And usually refer to them as terms. So these numbers right here, every element in the set, sorry, every everything in a sequence is called a term. But you can also call them elements or members. But we'll use term for today's lesson. So are there any questions about this before we move on? Hopefully that was a straightforward definition. Okay, sounds good. Let's get to some more technical stuff about sequences. So sequence notation. So how do we define a sequence? With graphs or something, we always have some equation such as y is equal to mx plus b or y is equal to x squared. But how do we define sequences? Well, so we define each sequence by a term. So a term is defined as a subscript n, where n is the term number. So say you have the first term, n would equal 1. If you want the second term, n would be equal to 2. If you want the third term, n would be equal to 3, and so on. Right? And sometimes we could also use a function notation, so f at n. But we're going to focus on a underscore n. So this notation at the top. This can be used, but pretty rarely. So now let's look at some other terms, other definitions, some new ones you probably guys don't know about. So what's the general term or explicit formula? So you can call it by any of these. But I think we usually use general term more often. But yeah. So what does this mean? This is a formula that's used to determine the value of any term without knowledge of previous terms or any other terms. Oops, sorry. So what does this mean? So here's an example, just to show you guys like the formula, the general term. So for example, you have a of n. So like the term defined as 3n. So whatever n is right here, you would substitute it into 3n to get your actual term for that term number. And then an example would be if you want the third term, so a at 3, so a3 right here, is equal to 3 times 3. So you substitute n for 3, and that will give you 9. So that means the third term in the sequence is 9. Right? Hopefully that was straightforward. Now let's look at the recursive formula. So we did learn about recursion in the past week. Now we'll go, a little bit more detail into that. So what's the recursive formula? Recursive formula is basically a formula that's used to determine the value of a term using knowledge of previous terms. So what does this mean? So remember that like in recursion, you had these like base cases, and then you have a recursive formula saying like a function that's defined by itself. So say you had like f of 1 is equal to 1, and then like f at n is equal to 2 times f at n minus 1 or something. This is very similar. So here's an example. You have, so remember we're not using a function notation anymore. We're just using term notation, sequence notation. So we have a of 1. So this is the first term. a1 is equal to -1. So that's basically your base case. That's defined. And then you have a of n is equal to a n minus 1. So basically this is like the current term you want, and then n minus 1 would be your previous term, right? So this will be your current term is equal to your previous term plus 3, right? So you want to calculate a of 2. So a of 2 would, if you use this formula, you would get a of 1. So 2 minus 1 will give you 1. a1 plus 3. And since you know a1 is equal to -1, you just substitute that into here. And that's how you get -1 plus 3 is equal to 2. And then say I want to calculate a of 3 and a of 4 of that. A of 3 would be a of 2 plus 3. So you substitute 2 into the formula, and so on and so on. All right. Are there any questions about this? All right. If there are no questions, let's move on. All right. If you didn't really understand the recursive formula, I don't think we'll be using this in the slides, so don't worry about it too much. But yeah, just the general term is more important for you guys to know. Okay, let's move on to arithmetic sequences. So this is a specific type of sequence. So what's an arithmetic sequence? This is a sequence where the difference between adjacent terms is the same or constant. What does that mean? Look at this example. Say you have 2, 4, 6, 8, 10, and blah, 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 so on. You notice that the difference between adjacent terms is 2. And what I mean by adjacent, like they're right beside each other. You can't take like the first term and the third term because there's a second term in between. That's not adjacent. So you see that difference between 4 and 2, that's 2. 6 and 4, that's also 2. 8, 6, 10, 8, that's also 2. So you see that this is an arithmetic sequence. Now let's look at what the general term for an arithmetic sequence looks like. So here's the formula. So you have a of n. Remember that this is like the term that you want to find at term n. So a of n is equal to a plus, in brackets, n minus 1, all that times d. All right, so what did these variables mean though? So we know that n is the term number that you want. So example, if n is 1, that means it's your first term in the sequence. What's a? So this a right here, not this a. Well, look at the a on the right side right, of the equation. A is the first term in the sequence, right? Sometimes we could use A1, but usually when you write down the formula, usually the formula just writes it as A instead of A1. So A is the first term in the sequence. And finally, what's D right here? D is the common difference. So remember we mentioned that each adjacent term has like a constant difference. That's what that's the common difference right here. So for example, in this sequence, the common difference would be 2. So just the difference between adjacent terms is your common difference. All right. Are there any questions about this? All right. There are no questions. Let's look at a problem. I think there's a problem coming up. There we go. Let's look at this one. In an arithmetic sequence, the third term is 5, and the fifth term is 11. Find the general term for this sequence. And you probably guys don't know how to actually solve this, so let's just do it together right now. All right, here we go. Yeah, let's use a marker. All right, so it's given to us that the third term is 5. Well, let's zoom in. Not sure why it's pixelated like that. Right. So we're given that the third term is 5. So the third term would be a of 3. A of 3 is equal to 5. Fifth term is 11. All right, so a question asks us to find the general term for the sequence. How do we do that? Well, do you remember our arithmetic, the general term for an arithmetic sequence? So we're going to use that formula to help us. So say, I'll just rewrite right here. So for any a of n, you would have a plus n minus 1 times d. And you can also put a d over here in front, but it doesn't matter. So say if say n was equal to 3, this would be a of 3 is equal to a plus 3 minus 1. That would give you 2d. All right. And finally, you have a of 5, where n is 5. You have a plus 5 minus 1 will give you 4. So that's 4d. All right. And also remember that these terms are already like defined, right? So this is equal to 5. This one's equal to 11. All right, let's see if I can erase something here. There we go. So I'm going to erase a of 3 and then a of 5. Now you can see that this is 2 equations and 2 unknowns. So we have a system of equations here. So we're going to solve for a and d. And that's how we're going to get our general term. So what do you want to do with these equations? We want to get rid of one of the variables first, right? To solve for one of them. And then we substitute back to get the other variable. So the easiest thing we can do right here is subtract both of them to get rid of a. So a would be gone. And then to subtract 4 will give you negative 2d. If you use 5 minus 11, that will give you negative 6. So that will leave you with, if you divide both sides by negative 2, d would be equal to 3. All right. Now we can substitute this into either of the 2 equations. Just do the first one, it'll be easier to do. So we have a plus 2 times 3 is equal to 5. All right, now if you solve for this, you should get a equal to negative 1. You should get the same thing if you substitute here. So a plus 4 times 3, a plus 12 is equal to 11, a is equal to negative 1. So now we have a Now we also have D. Now we can write our general term. So what does it look like? So we have A of n is equal to -1 plus n minus 1 times 3. And usually we don't like to have brackets. Here, see if, okay, I can pan down. Usually when you write these general terms, you don't want brackets around. So we're going to expand all this. So this is -1 plus 3n minus 3. So it's just equal to 3n minus 4. And that's your general term right there, right? That's the final answer. Are there any questions about this? So remember, for a general term, we're just solving for a and d's, and we just plug it into the general term formula. And that's how we get it right here. Okay. If there are no questions, let's go back to the slideshow. So those are arithmetic sequences. Now let's look at geometric sequences. Different type of sequence. What are these? So a geometric sequence is a sequence where the ratio between adjacent terms is constant. So we're no longer looking at the difference, we're looking at the ratio. So basically we're dividing a term by another term. That's what the ratio is, right? Here is an example. You have 1, 4, 16, 64. The ratio between adjacent terms is 4. So we do 4 divided by 1, 16 divided by 4, or 64 divided by 16. They will all give you 4. Right? So that's a geometric sequence. Now, what does a general term for it looks like? What does a general term for it look like? Here's the formula. So you have A of n. Remember, that's here. That's how we define general term. And then that's equal to A times r to exponent of n minus 1. Right, so let's look what these variables mean. So n and a, these stay the same from the arithmetic sequence definition. N is the term number. A is the first term in the sequence. What's r? R is what r is the difference between the two definitions. So r here is not the common difference anymore. It's a common ratio. So basically the ratio between two adjacent terms. That's your common ratio. For this one, r would be equal to 4. Right? Are there any questions about this slide? Any questions? Okay, if there are no questions, let's look at this problem. So here, in a geometric sequence, the second term is -6, and the fifth term is 48. Now find the general term for this sequence. Here, I'll let you guys think about it before you take it up. It's the same strategy that we used for the previous problem, but it's gonna be a bit, like a little bit different when you're trying to find A and R. It's basically the same strategy though. So just get your find two equations, like you do your system of equations. You get A and R, and you just plug them into the general term formula. Right. All right, I'll wait a couple more seconds, so like probably 30 seconds. Sorry if you don't have an answer right now. Let's take it up. All right, so we're given that a of 2, a of 6, and then a of 5 gives you 48. Alrighty. So remember that we want to find two equations, and that's how we solve for a and r. Not d this time, but r. Oh yeah, let me write down the general term formula again for geometric sequence. So this is a of n is equal to ar, and r is to exponent of n minus 1. Okay, so now let's apply this formula to each of these terms. So we have a, whoops. All right, so this is a of r, 2, so n here will be equal to 2, so 2 minus 1, that will give you 1. And that's equal to negative 6, right? So because n is equal to 2, a of 2 is equal to 6, so that means we can set these equal to each other. And we can do the same for this term right here, so a of 5. So this is a of r to 5 minus 1, which would be 4. And that gives you 48. All right. So now how do we solve these two equations? It's going to be a little bit different than the previous problem. So instead of subtracting them or adding them, like how you usually solve systemic equations, we can also multiply them or divide them. We can do that. So what we want to do is actually divide both of these equations. So just put division sign or something. Actually put a, I just put like a dash between them. So kind of like a fraction. You don't do that like when you're actually solving these, but like just showing this just, to let you guys know. It's division. So we're going to divide this equation by this equation right here. So we're dividing a by a. That will leave you with 1. A divided by a gives you 1, so we can ignore that. R to exponent 4 divided by r1. That would just be r cubed. Right? So because you just subtract the exponents, that's what you do. If you're dividing r4 by r1, you just subtract the exponents to get r3, r cubed. And then you divide 48 by negative 6. That will give you negative 8. 48 divided by negative 6 is negative 8. So if we solve for r here, so you can cube both sides, but just going to shortcut it. R would be equal to negative 2. So this would be your common ratio. Now we can substitute this into one of the two equations right here. Let's do it for the first one. So this would be 8 times negative 2 is equal to negative 6. So now we divide both sides by negative 2. That will give us a is equal to 3. Okay, so now we can write our general term. Let's write it down right here. So a of n would be equal to 3. So this would be an exponential equation, exponential formula, because they have the variable in the exponent. So this would be 3 times negative 2. And negative 2 is to the exponent of n minus 1. So remember, for a general term, we don't want to substitute anything for n. We just keep it as it is. Right? And we can't really simplify this anymore. So we just leave it like this. So that's your final answer. All right. Are there any questions about this? Any questions? Oh, Aiden, yeah, I defined it so that it's a geometric sequence, so you can't use the arithmetic sequence formula anymore. I'll always try to like define this what type of sequence it is for these kind of problems. So yeah, so you know what formula to actually use. Yeah. Okay. If there are no questions, let's move on to something different. So we looked at sequences in the first part. Now let's look at series. And probably none of you have heard like what a series actually is. So let's dive into it. What is a series? A series is basically the sum of all or first couple of terms in a sequence. Here you can see an example right here. So you have the first couple sequences. So you can take like the first term, or like the first two terms, or the first three terms. That's what I mean. Or you can just do all the terms. So from A1 to A of n, add all those together. And usually a series is expressed as, so using this notation, S of n, S subscript n, where you basically add up all the terms from the first term to the nth term. That's what S of n means. Add the first term, second term, blah, blah, all the way to the nth term. That's S of n. And we look back at this diagram here. So we see that so say take S of 3, you're adding from A of 1 to A of 3. And then S of n, you're adding up to A of 1 to A of n. Oh yeah, and then they also put this fancy notation right here. I'm not sure if any of you have seen it, but it's called sigma notation. This is basically like some special notation in mathematics used to like denote a sum of terms. That's what this means. But you don't have to know about it for today's lesson, right? Are there any questions about this? Any questions about what a series is before we move on? Okay, if there are no questions, let's go to the next slide. Let's look at an arithmetic series. So we looked at arithmetic sequences. Now let's look at arithmetic series. So what is that? This is basically the sum of all the terms. Well, sum of terms doesn't have to be all of them, just from 1 to n, right? So sum of terms in an arithmetic sequence. That's what that is. And it also has a special formula to go with it. So here it is. So you have S of n is equal to, so you have n divided by 2, and that's multiplied by whatever's in this brackets. So you have 2a plus n minus 1 times d. That's what's in the brackets. And let's also look at a proof of like how this formula came to be. It's good to know where our formulas came from. So let's look at what's over here. You share this new tab. So scroll to why does this formula work? Right. So this is where your proof is. So this part. So basically, look at it. You can see that first they define like a whole sum. They define a sum called S, and you're just adding up all the terms from A to A1. Sorry, A1 to A n. So here define A as the first term, right? And you notice that for each term after that, they add the common difference, as you can see here. So second term would be A plus D. Your third term would be A plus 2D, and your fourth term would be A plus 3D, and so on until you get A plus n minus 1D. So this was the actual like general term for an arithmetic sequence. Right? So A plus n minus 1D. And the next thing you did would be to write S in the reverse order. So they start with A plus n minus 1D. So they start with A of n, and then they go down to A1 or A. So now they put it in reverse order, like so. And now they add the two sequences. Sorry, now they add the two series, term by term. So basically they line up all the terms together, as you can see right here. And then they add them. They also have to add the s's too. So they're adding the two equations. So when you add two s's, you would get 2s, obviously. But when you add each of these individual terms, you get the same thing. So you would get this. You have 2a plus n minus 1d. So say we do this one. So a plus a would give you 2a right here. Same thing with this one. So a plus a, that would give you 2a. And then d plus n minus 2d. So we did, so yeah, you just add 1 basically to n minus 2. If you add 1, you get n minus 1d. And so on and so on. Get same thing for the other terms. And so you know that each term is the same, and there are n of them because there are n terms in a sequence. So basically just multiplying n by whatever this is, as you can see right here. But so we want to find s by itself, not 2s, we want s by itself. So that means we just divide by 2 to get the actual formula, which is down here. Here it is better formatted right here. All right. Are there any questions about this slide or this proof? So just Nor's formula. You don't have to memorize how the proof works. Let's go back to the slides. Any questions about this? Hopefully I'm giving you guys enough time to actually like copy down the formula on your notes or something. If you're taking notes, that is. Hopefully you are. Let me know if you guys need more time. But I think I'm going to move on. Let's go to the next problem. Let's look at this. So find the sum of the first 10 terms of an arithmetic sequence. So arithmetic sequence. Not looking at geometric, arithmetic. Find sum of the first 10 terms, where the third term is negative 14, and the common difference is negative 10. Okay. I'll let you guys, yeah. I'll give you guys like a minute to think about how you solve this. So remember, similar to the general term, we want to find a and d, right? But we're looking for like a specific number, so it means we also need n as well. So once you get all of those, then you can substitute those into the formula right here, and you're good. Give you guys a minute to solve it. Just curious, anyone have an answer yet or no? If not, that's fine. Right, assuming you guys are still solving it, I'll give you guys a couple more seconds. Okay. Yeah, let's take it up actually. Let's go back to the whiteboard. Let's use this space. Okay. So we want the sum of the first 10 terms. So I want to find S10. S of 10. So if it's S of 10, so that means n is equal to 10, right? So, let's write down the formula again. Let's write S of n. So this is n over 2 times, I'm going to write square brackets because there's brackets inside that. So we have 2a plus n minus 1. So n minus 1 times d. And yeah, that's the formula. So we want S of 10. That would be 10 over 2. And in the square brackets, we have 2a plus 10 minus 1 will give you 9. So 9d. So this is just 5 times 2a plus 9d. Right, and we can expand this. So we just say 10a plus 45d. So our final sum will be equal to this, but we have to figure out what a and d are. So what else are we given inside the question? We also know that the third term is negative 14. So a of 3 is equal to negative 14. And we also know that the common difference is negative 10. So d is equal to negative 10. All right. So remember that the general term for an arithmetic sequence looks like this. So remember it's a plus n minus 1 times d as a general term. All right, so for a of 3's, you would get a plus 3 minus 1. So 3 minus 1 is 2, so it is a plus 2d is equal to negative 14. Oh yeah, and we also know what d is, so we can directly substitute this into here. So we're going to write 2 times negative 10. And this is equal to negative 14. And if you want to solve for a, you would get a is equal to, so 2 times negative 10 would give you negative 20. Negative 14 plus 20, so you add 20 to both sides. That should give you 6. Yeah, a is equal to 6. All right, so now we can just substitute a and d into this formula right here. 10 times 6 plus 45 times negative 10. All right, just write down each of those numbers. So 60 minus 450. And that should give you negative 390 as your final sum. Right? So it should be the final answer. Right? Are there any questions about this? Any questions? Hopefully it didn't do anything wrong. Let me double check it. Okay, looks good. Okay, if there are no questions, let's go to the next topic. So we look at arithmetic series, now let's look at geometric series. And it's very straightforward. It's the sum of all the terms in a geometric sequence this time. And this is what the formula looks like. You have S of n, so we have the sum notation is equal to a, and this is multiplied by this fraction. So we have 1 minus r to exponent n as your numerator, and you divide that by 1 minus r. So this is the formula. Let's also look at the proof of how we got this formula too. Very similar to how we did the arithmetic series formula. All right, so same section. Why does this formula work? Yeah, this website's called Math is Fun. I know UI looks pretty old, but like it does some pretty good explanations of like some math topics. So you guys can take a look at that on your own time. But yeah, so let's see how we got this formula though. It's just a little bit more tricky than the arithmetic series formula, but same concept applies. So say you call the whole sum, the entire sum S. So S would be equal to, and you're just adding up the individual terms, right? Series is where you add up all the terms. So the first term would be A. The second term would be A of R, AR, because the ratio between each term is R. So if you divide AR by A, you get R. Same thing for AR squared. AR squared divided by AR would just give you R, which is a common ratio. So you have A plus AR squared, plus all the way to AR to exponent n minus 1. Remember that this is the general term for a geometric sequence, right? But a general term basically gives you like the last term, if n is the last term in the sequence. Next thing you do is you multiply all the terms by r. That's what you do right here. So now you have SR is equal to AR plus AR squared. So notice that A becomes the next term, AR also becomes the next term. Sorry, like the first term becomes the second term of the original sequence. Second term right here becomes like the third term of the original sequence, and so on. So and then at the end, you would get AR to exponent n. So, and now what you do is subtract these equations. So you have S, and then you subtract that by SR. So here they lined up all the terms for you. So instead of putting AR at the front, now they're aligning it with the AR from the original sequence. Saving for the other terms, and you do that all the way to AR to exponent n minus 1. And then you also have an AR to exponent n right here, which doesn't pair up with anything. And so whatever's left over, you see how these all cancel out. And whatever is left over, you have A minus AR to exponent n. So yeah, all these are gone. And you also have on the left side, S minus SR. And now we just want S by itself. So here we just use the distributive property. Well, this is what we have left. And here we just factor out S, and we also factor out A from these terms. And then once you factor out S, so this is S times 1 minus R, now you just divide by 1 minus R to get S by itself. And this is the final equation. S is equal to A times 1 minus R to exponent n divided by 1 minus R. Yeah, these two are the same formula. Are there any questions about this proof? Or like the slide? Let's go back to the slide. Hopefully you guys have enough time to, actually get that equation down. Any questions? Okay, if there are no questions, let's move on. Let's look at a problem. Same kind of problem. So find the sum of all the terms in a geometric sequence of 7 terms. So we're just looking at adding up all the 7 terms in the geometric sequence. So n would be equal to 7. If the first term is 80 and the fourth term is negative 10. All right, I'll give you guys a minute to think about it. Think about how we solve this. Very similar strategy that we used before. Actually, no, this is a little bit different. So you're not given common difference now, but you're given the first term this time. So yeah, it's kind of similar. Give us a couple more seconds. Does anyone have an answer to this yet? Just curious. Okay, I'll just take this up. Hopefully, you guys understand the strategy, though, like how you solve this. That's what's more important. Okay, so let me rewrite that formula. So the sum of a geometric series for a geometric sequence, a geometric series. So this is just a. Usually we put a in the numerator with 1 minus Rn. And that's all divided by 1 minus r. So remember, this is a formula for a geometric series. All right, what are we given? So we're given that n is 7. So we just, substitute 7 where n is. So this is just 1 minus r to the exponent of 7. All that divided by 1 minus r. We can't really simplify this anymore. I mean, you could figure out like how to factor 1 minus r to 7. It would actually factor out with 1 minus r, but you guys don't know. You guys don't have to know how to do that. But yeah, okay. So what other information are we given? First term is 80. So I'm just going to write a, not a1. I'm just going to write a is equal to 80. Remember, a is our first term. Fourth term is negative 10. Fourth term is negative 10. All right. So given our first term, given our fourth term, let's also write down what the general term for geometric sequence is. So you guys remember it. So it's AR to the exponent of n minus 1. So it's a general term for a geometric sequence. All right. So we can substitute some values in. So we can substitute a in here. So we have 80 times r. R is what we're trying to figure out. We don't know that. And n would be equal to 4. Well, say we're applying this equation to the fourth term. N would be equal to 4 minus 1. So let's rewrite that as 3. 80 times r to the exponent 3. That gives you negative 10. All right, now we have to isolate r by itself. So first divide both sides by 80. That should give you negative 1/8. Then you just cube both sides to get r is equal to negative 1/2. All right, so now we have r, we also have a. Now we can plug this into the equation right here. I think the number is going to, like a final answer, it's going to look a bit ugly. It's going to be a fraction or something, but we'll see. So this is just 1 minus negative 1/2. All that to the exponent 7. I just put 1 minus negative 1/2 or 1 plus 1/2 at the bottom here. So this is 80. 1 plus. So because exponent is negative, this final answer, like when you take negative 1/2 to the exponent 7, it will also be negative. And then it will cancel out this negative to get a plus, get a plus sign. So this should be 1 over 128. And whatever is at the bottom, we have 1 plus a half. That should give you 3 halves. All right. Let's do 80 times. So 1 plus 128, that should give you 129 over 128. And we're going to, flip the new denominator around, just multiplying it instead of dividing it now. All right, so now we have 2/3 instead of 3 halves. All right, we can cross multiply some of these terms. So I believe 3 can go into 129. That should give you 43. Okay, and then 80 can go with 128. So you can cancel out 16 here to give you 5. Cancel out 16 here to give you 8. And this 2 can cancel the 8. And this will be a 4. So what are we left with? 5 times 43 divided by 4. So that should give us 215 over 4. Okay. I'm actually not confident that this is actually correct, but that's how you that's how you get the final sum. Right? Are there any questions about this? Any questions? Let me zoom very quickly so I don't make any mistakes. Okay, I think I'm fine. But all right, hopefully you guys understood how I solved that question. Let's go on to some final problems. So there's only 2 of them. Okay. We'll do all of them today, hopefully. So in a local seater, so this is the first problem. In a local seater, the number of seats in the front row is 20. And each other row after that has 2 more seats than the one directly in front of it. So the one that's closer to a movie screen has 2. So the row that's further away from the movie screen has 2 more seats than the one that's closer to it. So the one directly in front of it. So that means if there are 10 rows in the movie theater, what's the total number of seats? Okay, I'll give you guys a minute to think about it, how you solve this. So we want total number of seats. Think about it as like some series, right? Think about it as like you're adding up the terms in a sequence. And so what is that sequence? Why would it be 2, Bob? So for total number of seats in this theater, you can see our first row already has 20 seats. So of course way more than 2. Yeah. Maybe you found a different value. Okay. Let's solve it. I think we're a bit short on time. Let's actually look at let's solve it. Look at the solution. Okay, so you want to express this question in terms of like sequences and series, right? How do you do that? So we're given that the number of seats in the first row is 20, and each row after that has 2 more seats. So let's pretend like each of these rows is like a term in a sequence. Okay? Pretend each of these terms is part of a sequence, and it's an arithmetic sequence because there's a common difference between each of the rows. All right, so we have A, the first term, so A will be equal to 20. So now each row has 2 more seats than the one in front of it, so that means that the common difference, D, is equal to 2. All right, and then we are also given the number of rows there are. So let's pretend that's n. N would be equal to 10. All right, so now we have this information. We want to find the total number of seats, and that's basically an arithmetic series. So basically the sum of all the terms in the sequence of rows. So this should just be S, right, S10. So this should just be S10. Here, let's write down the formula again so you guys don't forget. So remember, this is an arithmetic series, so it's this formula. All right, so now we have n, we also have a, we also have d. We just directly substitute those in. So we have 10 divided by 2. Now we have 2 plus 20 plus n minus 1 will give you 9. And d would just be 2. All right. All right, I'm just going to type the rest out. I think it'd be easier to type now. That is a very small font. A bit too big. There you go. Okay. Sorry, I'm getting used to this platform as well. You can see I'm moving between whiteboards. Apparently, the one I was using last week, apparently the software, like, I don't know, the company got bought off by another company, so now it's yeah, it's no longer there anymore. So kind of unfortunate. Okay, so we have 5. 2 times 20, that would give us 40. 40 plus 9 times 2, which is 18. 40 plus 18. And if you solve for that, just do it in one step. That should give you 290. 40 times 18, 58 times 5. That makes sense. Right. So that's your final answer, 290 seats. Just put C's right there. All right. Are there any questions about this? Hopefully you guys understood how we got A, D, and N. That's the most important part.